Oh, there we go. All right. Do you use any of the math that you learned in discrete math for programming?
All the time, yeah.
Really?
Yeah.
I'm going to need some examples of that.
Yeah, I use sets. I use differences of sets. I use Boolean logic. I do graph stuff all the time. With all the rules and the trees and the pathfinding stuff.
Do you ever use any proof techniques?
I had to prove something once. I ended up not using it, but I was doing this tricked out optimization thing for no reason. It's very clarifying thinking about bijections and like equivalence relationships and stuff. Like in Rust, literally the equivalence relationship is like in the type system. It's all like it's very real.
Like an equivalence class, you mean? Like things that are equivalent on a property but not themselves?
Well, so you have the equality override, function override thing, and that's a trait. And then you can also have a trait on top of that called EQ, which promises that it is actually an equivalence relationship. And like if you want to put something into a hash set, you have to tell it that it is eq. And it's like it has ord 2 for things which have a total ordering over them. And it's like floats do not, because IEEE 754 did not do that. But the integers do, and it's annoying because you can't use...
Floats can't be ordered?
There is no... So most of the time they can, but there is not a total ordering because nan can't be ordered and follow the ordering rules. Nan and infinity...
Right.
And negative infinity.
Couldn't you just define special cases? Well, I guess it doesn't really make sense. Like nan. Nan is always less, but...
Well, it's like not even... It's just not comparable.
Yeah. Yeah.
They could have, but Rust decided to make everything not fun. I mean, it's also like if you do that, then you have to start having if statements and stuff. Or I don't know, maybe there's special CPU stuff. But what's...
Can you define a monad?
Did not learn that, but it's like a taco or a burrito.
I think it actually is just like, isn't it? Isn't it like a specific like wrapper in math? It's like a wrapper object basically that like just attaches to like one kind of thing and like gives it some extra properties, and it allows you to like keep using it. Yeah,
I mean I've used it a few times in programming. I mean, like the option type in Rust, it's just a value, and the abstraction is that it may not actually be there. And then there's like logging monad, where you can do operations on the value and log that value changes, and then later you can get those. There's like a...
Yeah, isn't Rust like heavily make use of monoids?
Is result a monoid? Is a monoid a monad?
Oh yeah, what is a monoid versus a monad? So a monad, result is a monad, but what's a monoid?
Like a lot of these things I just don't even think are real.
Yeah, I don't either.
Like I actually went down a Wikipedia spiral trying to figure out what they all meant, and it was like, well... I guess, if you think that's going to be important, and it probably is, but a monoid is a set equipped with an associative binary operation and an identity element.
Associative, so it's like less than a group. It doesn't have full group properties. It's... What grade are you in? We're in 9th grade. All right. I was trying to find the page. We're doing discrete math from this book I got from Carlos. Well, Carlos didn't give it to me. He recommended it. It's used at the University of Manchester. All right. No, this problem 1, mathematical statements and proofs. That's not good. Let's see. How about this one? Do you think you could do this? Prove by contradiction that there does not exist a smallest positive real number.
Yeah. The smallest, so like, does this include, is absolute value the smallest, or is negative the smallest?
Negative is, I guess it's absolute. That's a great question. I guess it's absolute value, yeah, because negative is like big in the negative direction. Like negative a billion is like a lot, but negative.
Yeah, I mean, we could do it either way. Do you have any guesses?
I would say it's like I would say it's like closest to 0.
Oh, well, I mean, yeah. I mean, guesses for the answer to the question.
Oh, it said smallest positive also. Smallest positive real number. All right. So assume towards a contradiction that basically, so we've got a smallest positive real number. And we want to prove, this is probably not going to show up at all. I guess I can zoom this in more. Bear with me. Man, software sucks.
You guys can't see this, but to make anything bigger on ODS, you have to like drag the corner of the camera thing and then move the window over so you can drag it further again.
And now I can't like see how zoomed in it is. So that's legible. Just gonna have to write big.
I don't know. Until we get to some hard questions, I don't think we could just talk about them. Oh, look at that.
That's visible. Yeah, we don't have to actually write anything down.
I mean, like, is this where you're at with what we're doing?
I think it's a good warm-up problem. I mean, yeah, like, I'd ideally like to practice, I don't know, just a few different kinds. Like, so I don't know if this is honestly like a trivial question either.
It is.
Is it?
Yeah.
Maybe I'm just really bad at math. So there does not exist a smallest. Yeah, we don't have to write that down. So there does not exist a smallest positive real number. So if you assume there does exist a smallest real number, smallest positive real number, say x, where's the contradiction?
So the statements you have to contradict are, well, that there is a smallest one, and the statement there is that there is no smaller number. So it's possible to have a number for which there are no smaller numbers. And to contradict that, you gotta be all like, well, there is a smaller number, dude. It's this.
Wait. We're trying to prove that there is no smallest number.
Yeah.
Okay, so then we're like, sorry, bear with me, I'm dumb. So then we're like, yeah, there is a smallest. So assume there's a contradiction that there is a smallest. and we want to show that the fact that that assuming there is a smallest x leads to something that's impossible. And man, I'm so rusty. I'm not seeing the path forward from that.
Yeah, so you could just take any arbitrary, say you have x, you can construct a smaller real number by taking half of x. And that's the contradiction. Because for any real number you choose, no matter what, there's always, you can just take half of it and get a smaller one. So there is no smallest.
Okay, so yeah. And that contradicts the assumption that it was the smallest. Let's see. All right. That's pretty easy. What's your goal learning all this? Ideally, like, it's because girls like it.
Yeah, I've actually heard a lot about, like, I've overheard some women in the library talking about guys who know, what is this stuff again?
Discrete math. There was this one girl, yeah, she was like, oh my god, and then he knew the piano axioms for proving number theory things, like, just by heart, and he was just like whipping out number theory proofs, and it was so hot. So
they're really shy about it. They feel like they're sluts for liking people who are good at math, and there's like this really negative stigma about it. So don't like go out and ask them directly, or it'll
offend them. Yeah,
but they do.
Yeah, society really, like, it's totally society's
if
fault.
You're just a woman in this society, you can't be interested in men who are good at math. It's really not.
Yeah, but
it's really sad, guys, and it's really not so serious.
That doesn't mean that men shouldn't be allowed to pursue math for the sake of getting women.
And it also doesn't mean that you can't pursue math just for the sake of pursuing math and not doing it for the women.
Right, that's not what we're doing, but no shame to anyone who's doing it because they like math and is totally gay. All right.
I don't know which of these are going to be interesting. Also,
that was like easy as
there's
hell.
more here than discrete math.
What do you mean?
Well, I've never seen that double discrete. Capital pi thing.
Oh, that's, sigma notation?
Multiplication.
Yeah, exactly. This guy picks it up quick. Look how legible this is. You can almost see a single symbol. Yeah. I wonder if there's a better way to do this. Maybe it has to do with the fact that the phone is on the ceiling.
Yeah, we're hanging. Well, I mean, look, nobody's here to learn math, Sylvan. They're here because I don't know why they're here.
Well, they're here to. I think they are here to learn math.
Did you tell them that there was going to be math?
Oh, yo. Some guy donated. Upvote this comment for a drunk shower video of Sylvan with his dude.
Is this picture a Minecraft picture?
No, this is this other YouTuber from South America. He's from Guatemala. Yeah. What's up, Linkarzu? I did a couple interviews with him before. For some reason, people care about what I have to say, which is not really that optimal, to be honest. Okay. That I feel like this question is boring because this is just like this is essentially like the properties of summation notation, but like with. I feel like it would be better to prove. Dude, you just destroyed that. Oh, this one. I read this the other day and I was like, this is gonna be bullshit. Okay, prove that for a positive integer n, 2 to the n times 2 to the n square grid with any one square removed can be covered using L-shaped tiles of the following shape. Like, this book previously hasn't covered any kind of geometric proof techniques, so yeah, too bad you can't see the pages. Just listen to it. I actually do feel kind of bad for them, to be honest. Maybe I should get my phone off the ceiling and reset this, but...
So wait, we have a square grid and its dimensions. The dimension is 2 to the n.
Yeah.
And n is a positive integer. And we're going to remove any one square from the resulting grid? Like, can we remove one from the middle?
Yes.
Oh, so okay, and then we have these L-shaped tiles, and we can use any number of the L-shaped tiles. All right.
This is going to be interesting, though, because, like, we can give examples of this geometrically, but this should be proved probably inductively. Like, we're going to need to convert this to algebraic representation somehow, I think. Hold on one sec. I know you expect high quality from me, but...
Can you hold down control and then scroll and make it?
Oh, shit. What if that's true? It is not.
Can you pinch with the trackpad?
Nope. We only get corner zoom properties. I don't know. We're going with corner zoom. Ready? Yeah, it's basically Tetris. This is going to be... I'm not really sure how to go about proving this, to be honest. Hopefully I didn't just dox us. Oh, thanks for the $5, by the way. I don't know if I thanked you. That'll buy me some ramen. It'll keep me alive for another week. Unfortunately.
Hey, Sylvan, in your classes, do people use pencils still?
No, pencils are pretty obsolete.
Mechanical pencils?
No, those are a thing of the past.
Pens, really?
No, I don't know. I just happen to have a pen. Would you prefer a pencil?
No. You know, what I've realized is that pencils are just totally terrible and stupid, and I don't know why they make us use them.
Do you prefer pens?
Yes.
Why? You can't erase pen, though, unless you erase really hard for a long time.
First, just don't make mistakes. And, second, if you're, okay, the situation where you're not going to be erasing your pencil, you just cross it out and get a new paper anyway.
Right.
Nobody's erasing an entire page. And if you're writing an entire page of mistakes, stop writing and think about what you're doing.
Yeah, that's true. Erasing a whole page of mistakes. Imagine I feel like it's, you know how like all the light bulb companies banded together and then they decided like unanimously to like make all the light bulbs shitty so they could keep selling more light bulbs?
No.
Well, there's like a technology for like a light bulb that lasts for like 10 years or something without replacement, but all the light bulb companies were like, well, we're fucked if that gets out, so they all agreed to just make the shitty kind that burns out quickly.
Well, that's illegal. They can't do that.
Apparently they did. Someone in chat backed me up here, so
Dude,
it's the same thing with erasers though. Like,
if there's proof of this, then they're getting sued into oblivion right now because that's illegal.
I don't know. If you look at the current state of the world, things are not exactly big corporate entities are not really the ones losing. Okay, this is...
I don't know what your success plan for this is either.
Oh, I'm getting a chair. That's what we're doing. Do you have any ideas on how to do this problem, by the way?
Yeah, I think it'll be pretty obvious once we start drawing stuff.
If you were gonna make like an NSFW game, by the way, that got me thinking. Like, you'd have to do a lot of. You'd have to be looking at like really pornographic scenes all the time.
Yeah, you thinking about going into the industry?
Not exactly, but I don't know. It'd be interesting to be a. Okay, this is outrageous. This shit is.
So I don't understand. Are you even trying right now, or are you like?
You give it a shot. This thing is not moldable. Oh man, I lost the page too. I almost kind of enjoy making bad content, I will confess. Oh, some random guy said the light bulb thing is real, so...
So, yeah. Alright. Are we there?
Oh, hell yeah, dude. How did you do that so quickly?
I'm just that talented, Tillman. You're my level. I already completed this class.
I did too. It's been a while. Alright. So here's the question. God damn it.
Oh. They don't mind, though.
Now you're getting it. Yeah, can we rotate it? Transform. Yeah. Flip horizontal.
Alright, well.
Now we gotta...
It was a guess.
Well, you could drag it over.
Thanks. Alright, I'm just pressing the wrong buttons at this point. I don't know how.
I hate those streams where like people know, like, you know, where it's like all they've got their neon lights and it's like they've streamed a lot before and they have their setup well defined and like those just it's all shaking. Those just suck. All these are trivial, bro. Shut up. If they're so trivial for you, then go. I don't know. You solve the Riemann hypothesis or something. All right, so we're looking at number 20 here, which is that prove that for a positive integer n, and 2 to the n by 2 to the n square grid with any one square removed can be covered using L-shaped tiles of the following shape. L-shaped tiles of the following shape, like they were going to be O-shaped or something. It's a little bit redundant, but all right. So this is probably an induction problem, right? So you show P1 and then you show Pn implies P to the n plus 1.
Yeah.
Which means that it would hold for all n. And so you remember the difference between strong and weak induction?
I can't remember what that is.
This weak induction is like...
My intuition is that it's not a real thing.
That's fake. Well, weak induction is like... So you show P to the 1, right? So you knock over the first domino, and then P to the n implies P to the n plus 1, which means you've knocked over one domino, and you have that knocking over any domino knocks over the rest of the dominoes. Therefore, for all integers, you've proved it. But strong induction is like the equivalent strength, but it's like
we're really sure, though.
Yeah, it's instead of assuming like P to the n implies P to the n plus 1, you assume P to the, like, all the previous n's imply P to the n plus 1. Like, it has the ability to look at every domino that's been knocked over. It's not just like the last domino. But, so, the trivial case here, right, it's for 2 to the n times 2 to the n, it's like very obvious that this works with a 1.
Yeah, draw it out. No.
Yeah.
My very small brain.
So any one of these you remove, that one for instance, that's clearly... Is that an L shape?
Yeah. It is.
Yeah, you're right. So then the next level is that's 2 to the 0, right?
It's 2 to the 1.
2 to the 1.
N is a positive integer.
Oh, right. And 0 isn't positive last time I checked. Bye. Thanks for the $5. So then if we up this bad boy to 2 to the 2, which is 4, which means I would draw 3 lines. And then we remove any one of them. This is also spanned by L shapes. So anything we remove is going to be successfully spanned by L shapes. This I buy because, like, right, so you remove this one. This is an L shape. 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 That's your borders. Then that's also an L shape.
If we remove a corner one, how do we do it?
That's a good question. So I guess I'll redraw this. This would really ideally be done with graph paper, but...
No, graph paper is for posers. Like, if you can't just draw the thing...
If you can't draw squares, you don't deserve to...
Life doesn't have graph paper.
All right. So... Yeah, remove one of the corner edge piece or corner pieces. Let's try edge, I guess. Seems jankier. So you can fit an L like that, an L like that, an L like that.
Can't complete
Fucked
that.
up.
No. So we can't get into any situation where we have 2 in a row like that.
Well, this is possible.
I don't think it is. So we have to put one here because we have to fill this corner spot. And then these 4 have to be filled. So we either go this way in the corner or we go this way in the corner.
Right.
And in either of those ways, to then fill these 2, we have to complete the... Oh, no, we don't. No, we don't. We go this way and then
it
that.
is possible, right?
Okay.
Right. So we do that, and then you would do like this. Is that the next best one? Because if you go there, then you're fucked. So you'd have to fill like this, right?
Yeah.
And then you'd have to fill like this, and then like this, and then like this. Okay, so that's possible. And similarly, this though doesn't like prove this, right? Because we'd have to do this for every grid.
Yeah, we just gotta keep dawdling around until we see the thing that's always true and we add more.
Yeah. So on the corner instance, let's just look at that to build intuition. If you don't know what we're solving, literally go back in time in the stream 30 seconds. Okay, I gotta draw 3 lines. This is fucking terrible. See, maybe graph paper is worth it. Okay. Corner. So what do you do in the corner case? You gotta do this, right? No.
Yeah, but we can do it that way. So go ahead and do it, and it's fine. And it's like... And then we always have the one in the middle that's the L, and then we just go around the edges.
That was easy, yeah. Yeah.
Alright, so here's my algorithm for how to do this.
Okay.
Is anytime we have a power of 2, it's going to be made up of these single 4 things.
Right.
And we know how to do... Like, we can break up the 4 into the quarters. And no matter which one is missing of the 4, we always know how to do it. And then... that will have filled one of the center 4 blocks, and then the other 3 center 4 blocks get an L, and then we put L's in the corners.
I see. So that will have filled one of the other center blocks. But this case is weird because it's like this I agree with.
But if we take this case and we just rotate it to the center, the blocked out one is over there, like it's equivalent. Well, they're equivalent. Because after you take care of the 4 that contains the missing one, the rest of the puzzle is always the same.
I'm not understanding that geometrically. If you rotate it, like what do you mean?
I mean, so like, we have the...
Wait, get it more on screen.
It's only 3. I'm so dumb. So it made it look so easy. Alright, so like always, we can cut this into 2s.
Yeah.
And then the dot must be in one of these 4 regions. And in any one of the 4 regions, wherever we put the dot, the other 3 will be the L. And then the rest of it is just a bigger L. And we always know that we can do the bigger L.
The other 3, so we're putting the dot in one of these 4 regions. Oh, I see. This is just like a recursive problem. So we put it here, and then we make the L, and then we can just fill the rest of this with, it's the same thing, with L's. Yeah. So, like, I understand geometrically how this works, but I don't think that constitutes a mathematical proof, right? Because that doesn't... You'd have to show that, because they're asking... I think they're asking to prove it for all integers.
Yeah, I mean, it looks like we're just going to use proof by construction.
For any positive integer. What do you mean proof by construction?
Like, we'll just write instructions for you have n is a certain value, and then you increase n by 1, and clearly by just taking the solution and then filling in the L, and there's no way the instructions could not work.
P of 1 is trivial. So we have P of n, assume P of n implies, and we want to show. So that's the induction hypothesis, and we want to show that P of n implies P of n plus 1. But this is weird, like, I guess, I guess I'm not exactly sure, like, how to write this out as proof by construction, like what the...
So start out by saying that we have the square of n, and we've shown that that square, which is missing 1, can be covered in the L's.
Well, we have the square of 1. Oh, and we're assuming the square. Yeah. So we've assumed P of n. Yes. Okay. So we have that 2 to the n by 2 to the n can be covered by L's by inductive hypothesis. And I feel like there's going to be some kind of algebraic rearrangement, because we have this as, we've assumed this is true. 2 to the n can be spanned by L's. What we want to show is basically like 2 to the n plus 1 by 2 to the n plus 1 can be spanned, and
Yeah, so just draw the square of 2 to the n and label the edges n, and then draw the larger square that contains it.
Okay. So we have a square with n, well, with 2 to the n, 2 to the n, and then a larger square.
No, the one, like, it goes around the square.
I see. All right, that square will be artistic, whatever. 2 to the n plus 1. 2 to the n plus 1. Okay. And any image L by taking the corner case solution. I'm not sure exactly. Do another induction for larger L made of small L's. Writing this out like actually rigorously is quite difficult.
So look, I mean, so this outer square you've drawn proportionately, but I'll just say out loud that it's twice as big on each dimension as the smaller one. And
True.
all of those 3 corners are exactly like the first one, except they aren't missing a spot. And to put an L in, you need to have 3 spots, and you can always put them in the middle.
Right.
Like, we've already assumed that it's possible if any one of those spaces is missing to cover that rectangle, that square in L's. So we can just make that same assumption for these other parts, and that there's one missing, and make the one missing the middle one.
I see. Yeah. Right. For some reason the plus 1 and the 2 to the n, it didn't click for me for a second that it's a double. For some reason I was thinking like the plus 1 was on the outside. Okay. So I don't know if this is like sufficient to do visually, but that seems like a good enough argument. And we know that all of these can also be covered by L's, which shows the inductive hypothesis is true, which by induction makes this true for all integers. I don't know if you have to write anything on it.
Yeah, I mean, if you want to practice writing out the sentence, you might be some specific words you want, but or we could move on.
Just for practice, like what would you say?
Well, I'd say suppose we have a rectangle or a square of 2 to the n boundary, and we're going to assume that with any one hole missing, that we can cover the rest of it with L's. Now we're going to take a n plus 1 square,
Yep.
and we're going to put that first square in the corner of it without loss of generality, because we could put it in any corner, and any square inside of it could be missing, which corresponds to any square inside the entire thing being missing. It's all the same case.
Yes. Wow, good use of without loss of generality.
And then we just have to prove that the rest of those spots can be covered, and they can be, because of that initial assumption. We see that any of the 3 new regions, which are of the same size as the region that we're assuming, we know that they can be covered with 1 spot missing. And we're just going to make it so that the 1 spot missing is the 3 centermost ones. And we'll cover the 3 centermost ones with an L. And so it must be the case that they're entirely covered. And that proves that P of n proves P of n plus 1. And then we just got to do talk about how we can rotate this thing to do whatever we want.
Right. Which, I mean, you could say probably in the in both this assumption and the P to the N assumption that it holds true without loss of generality, and that would be sufficient, I guess.
What'd you say? What?
Like you could just say that, I mean, they're all the same thing under rotation for both. You could show it in P1. I guess you're never going to use P1 especially in this part of the proof, but I don't know. I feel like this has been adequate for this one. I don't think anyone would.
Nobody doubting in the chat. Nobody batting an eye.
Yeah.
Come on, guys. We can't cover all the squares. There's no way.
Putting an L in the middle to remove a square from one each. Yeah. And it's not like, well, they did say like you removing any square, it would still work. So I guess that's like it might not necessarily be the middle one, but we know that we assumed that was possible in P to the N. So all of these are just P to the N's. Like anything you remove, any square you remove inside of them, it doesn't matter. All right, let's hit another one. Let's see. What looks... This one might be good. You were using a circle algorithm.
What one is it?
Suppose that n points on a circle are joined in pairs. The points are positioned so that no three lines are concurrent in the interior of the circle.
What do you mean joined in pairs?
I'm not exactly sure. N points in a circle are all joined in pairs.
So we're just going to randomly pair them? Like, is n even?
N has to be even if they're joined in pairs.
Is it joined like a British word?
This is a British textbook.
Is it an inner join or an outer join?
Is anyone here British and does maths? Do you know what this means? All right. Suppose that n points on a circle are all joined in pairs. Okay. We all know what that means.
Are they on the boundary of the circle?
Yeah, n points on a circle. Clearly they're on...
They're not in the circle? I mean, is the circle opaque?
They would have said in if they meant in. They're on top of the circle. Although, I'm assuming that's circumference.
This book isn't rigorous enough for me, guys. We gotta get a new book.
The points are positioned so that no three joining lines are concurrent in the interior of the circle.
What is concurrent?
Come on, you're a programmer. You know what concurrent.
The interior
three
of the
joining
circle?
lines are concurrent in the interior of the circle. Let A sub n be the number of regions into which the interior of the circle is provided. Oh. Concurrent, they must mean... so the points are positioned so that no three joining lines are concurrent. So, like, for instance, we hold this open for a sec. If you have a circle and we have n points that are in pairs, we all learned British English at school in the EU, but no, I don't understand. Yeah, this is barely English. So let's say there's points like say like A1, A2, B1, B2, C1, 1, C2. And they're all positioned so that no lines are concurrent. I think just means that they don't, like, they're not the same line.
So then why wouldn't it be two joining lines are concurrent?
I'm not sure.
There are endpoints on the rim of the circle. There are endpoints on a circle, and they are all joined in pairs. No. The points are positioned so that no three joining lines are concurrent on the interior of the circle.
No three joining lines. It means that where lines cross, only pairs of lines cross, not triples. So, like, this is illegal. Like, if a third line was to go through.
Oh, okay.
Lou 9 saved us. Probably some kind of math genius.
All right. So, that's the setup. And then it says, let A sub n be the number of regions into which the interior of the circle is divided.
Oops, that was an A sub 2. Fuck!
So I guess implicit in that sentence is the whole idea that it doesn't matter where we put the dots or the lines. It's always the same amount of regions.
Really? No, because if A1 was over here, you would have an extra region, right?
But that would be concurrent with B's and C's.
Is it? I thought they just weren't allowed to cross in the same place.
Like over the same point?
Suppose endpoints on a circle are all joined in pairs. The points are positioned so that no three joining lines are concurrent in the interior. No three joining lines are concurrent. What the fuck?
So they're claiming to have a deterministic thing that tells you how many parts there are. So probably anything you can do to cleverly change the number of parts is not the right answer. But also maybe that doesn't change the number.
So A to the n is the number of regions into which the interior of the circle is divided. Draw diagrams to find A to the n for n is less than 6.
But that's just the baby instructions. We're just going to intuit what the it is because it's so obvious.
Is it?
Yeah. Anytime a book says that you're going to have to, here, do it this way, I'm just like, no. All right, and then this is the formula that they think is the answer, and they're doing. I gave up trying to know how to do that, so fuck that.
So they say prove A to the n is A to the n plus A to the n minus 1 choose 2 plus A to the n minus 1 choose 3 plus A to the n minus 1 choose 4.
No, it's just n minus 1.
Plus n, okay. Or alternatively, 1 plus n times n minus 1 times n squared minus 5n plus 18 over 24. Intuitively. Here, m choose r denotes the binomial coefficient. Oh boy. This one is going to be brutal. How would you exactly let A to the n be the number of... I'm still somewhat confused about this. No three joining lines are concurrent. Like, what's a concurrent line? What is concurrent? Concurrency is outside of programming. What does that even mean?
So I think the chat guy, it's just that if the lines are touching, they're concurrent.
Existing. Yes. Or three or more lines meeting at or tending toward one point. So meeting at one point, they can't.
Or what if they tend towards the point? What if the lines I really like those points and they tend towards it?
Meets at the same time. Yeah, so they rendezvous. And they want us to draw diagrams to find a to the n for n is less than or equal to 6.
Dude, I can't draw 6 diagrams. Oh boy. So look, I mean, okay, what we're going to discover is that every time we add a line, something very obvious and predictable happens. And then we're just going to induct on that formula by putting n plus 1 in there. So actually all we have to do is show the base case and then do algebra.
Okay, so this... wait, I'm still slightly confused at, like, moving this A2 to here so that this crossed an additional time. Doesn't that create an extra... Am I dumb? Like, aren't those two different... two different amounts of...
Yeah.
Like, that seems...
So we just must not be able to do it. Not real.
That's... the problem doesn't say anything against that, though.
Well, it says that it's determined only by n, so it does.
To find a to the n... Yeah, you're right.
Now, I'm also not hearing that n is even. But they're subtracting n.
That's a good point.
In that formula, they're subtracting n. So it's got to be at least 2, because you can't choose anything from 0. Or maybe you can. And it's got to be a whole number. So like this dividey thing must end up being an integer, which means that m minus r must be an integer. And m and r and r and r, you know.
Yeah.
And r factorial times m minus r factorial must divide m factorial.
What an outrageous formula for... So what they're saying a to the n is equal to, I guess I'll just write that for, is n plus n minus 1 choose 2 plus n minus 1 choose 3 and choose 4. Okay.
Now, I don't know about you, but when I'm operating in the world, I don't choose. I don't do that. I mean, that was never a real thing in my mind. It was like, what are we talking about?
That's just that's basic combinatorics.
Combinatorics is not. I could do combinatorics. I can't do this. It's not even real.
That is combinatorics. It's just the number. It's how many ways can you choose 2 things from n minus 1 things. Like if this was 1 and 1, how many ways can you choose 1 thing from 1 thing? It's 1. Like if you do the math out, it maps to that real world thing.
I mean, you can only ever take one set of things, and you can just count. Like, I mean, I just do the factorial in my head. It's like, yeah, it's factorial.
Yeah, but it's different than factorial because just plain factorial is permutations of like how many ways you can arrange the thing. This is like how many ways you can pick n things from m. How many ways you can pick n balls from m sacks.
Dude, I've never ever had that problem.
What? That comes up on the daily. You ever like rummaging around in your sock drawer and you're like,
no, I leave all my socks on the floor so that I don't have to.
All right, so you're rummaging around on the floor looking for your socks, and
the floor is just one container. There's no need to pick from multiple containers. I only ever need 2 socks, and I know that by picking any 2 socks, I will have picked 2 socks afterwards. That's my theorem, personally, that I've discovered.
It's like Ewan and his like coffee pressure measurement. No offense, Ewan, if you're watching, but god damn, that's useless. See, this guy has multiple sock drawers. All right, but The problem here, this is still glaringly obvious, is that the number of regions this should be, which if we count it, 1, 2, 3, 4, 5, would go up by 1 if you moved this A2 over here, right? Which is just like absolute lunacy.
Is there a bound on n in the problem?
That's a great question. Prove that a to the n is given by the following formula. There is no bound on n.
So, like, this is a problem because if I have n is 1 and I subtract 1 from n and then I choose 4 from 0, what the hell is even that?
That's a good question. What would that be? Because the formula for choose is m factorial. The top thing factorial. So it would be n minus 1 factorial. Oh, true.
I mean,
that's
you can't
going to be negative.
factorial of negative nonsense. I mean, it's just...
You can if you... What's
So,
that
I
function
feel like
that
that-
approximates the...
Well, it's a whole different function. So they say in the thing, draw diagrams for a sub n where n is less than or equal to 6. I feel like n has to be at least 6, and they put that thing backwards in the problem.
To find a to the n for n is less than or equal to 6. I mean, here, like, it's got to be n is greater than or equal to 0, right? Because you're not going to draw negative points on the circle. That's not possible. So I think those are their bounds. They're just kind of implicit. Right? Like, just physical geometry. You couldn't draw negative points.
I mean, the function they've given us just isn't defined for n below 5. And if you don't have an even number of points, you can't draw a line with that point. And I'm assuming that we can't share points for lines, but the problem isn't being super clear about that. So, like, probably n is at least 6 and is even.
N is at least 6 and is even? I mean, but they say to find it for n is less than or equal to 6, which implies that they would want you to find it for a 0 to 6.
But I think they just typed it wrong, because what could it even mean?
No, we've got to just be misunderstanding what it means to choose, like, NCR and choose R for, like, what does it mean to choose, starting at 0 points, what does it mean to choose -1? Like, what? I'm sure we could just whip up Desmos and I mean...
Well, you can't. I mean, we have the definition. It requires taking the factorial of a negative number, which is not defined. Maybe in England they have negative factorials.
They do have negative factorials. That's a thing, but it's like the graphing calculator.
What's Desmos going to do?
I just want to see, because they have an NCR formula. It's probably that. I just want to see, like, what a... Like, so for the case of 0, like, -1 choose 4. See, it is defined. Also, just out of curiosity, what's -1 factorial? It's -1.
What's -2 factorial?
Oops. Jeez. -2.
No, Desmos is just...
-6.
Thinks that we're emphasizing the number. Okay.
You ever seen the generalized factorial formula? It's freaky.
Maybe.
So this is defined. As it turns out, choosing -1 thing from 4 items.
Is it just doing order of operations? Yeah. Can't have factorial negative numbers. Bruv.
But the NCR is working.
Dude, I think it's just making stuff up.
Is it? It has to be possible, though, to choose a negative. I mean...
Look, I mean, I don't even believe in this. I don't think it's a real thing. But if I did believe, I wouldn't believe that. All right.
What would you believe?
I believe that that's just a bunch of factorials with stupid circles around it. I mean, what?
It sounds like a case of unfamiliarity.
Yeah. And I'm not going to get familiar because it's dumb.
I mean, all it is like...
Yeah, I mean, I've done it a million times. I could draw out the definition, but then I'd have to follow it by saying this is useless, you'll never need it.
That's not true, though. It's used all the time. Like in the sock example. It's n factorial. Plus, I have to know this shit for number theory. Like, the binomial theorem is important and makes the world go round. Or something. So I don't exactly... Like, if you plug in -1 and 4 for this, like, -1 factorial over 4 factorial and times 5 factorial.
Could you open Chrome so I can look up typos in this book? I bet you it's a published typo.
No way. Google it yourself. There's no way.
What's the book called?
An Introduction to Mathematical Reasoning, Numbers, Sets, and Functions by Peter J. Eccles. I actually did see a typo earlier in this book, so... n-1. So, -1 and then m minus n. So it would be -1 minus 4. -1 minus 4. That's -5. Yeah, this is a little suspicious, I'm not gonna lie. What is -5 factorial?
I can't find anything.
I knew it. 5 stages of grief denial is the first step. No, it's not real math. I don't believe that. It is brutal. They're asking us to define... Okay. Well, what we can do, they do give the option. If you would prefer to not deal with that, we have the formula 1 plus n times n minus 1 times n squared minus 5n plus 18 over 24. Which is way more intuitive.
That could be real. I mean, at least there's like a cube or something right there.
All right. That seems more real.
All right. So look, every time we do something like this, we add 1. We add 1 when we add this one. If we add another one without making 3 of them concurrent, it'll go from here to there, and that will add 2. So, but you could also put 1 here and here, and that would only add 1. So we do not understand the problem.
That's what it seems. I just don't get how... It seems like it's in 2 states at once. Like, a to the n does not seem to be predicted by this. Actually, this just implies, we don't know the rules. The points are positioned so that no n points on a circle are all joined in pairs. The points are positioned so that no 3 joining lines are concurrent in the interior of the circle.
Is that the word for parallel?
No, it's that they apparently can't join by 1 point.
I mean, that's like fucking... Like, okay.
Oh, I think you're supposed to connect all the points, all the pairs.
No, because I tried reading it like that, and there was something that told me it wasn't.
The points are all joined in pairs. Oh.
Is it really?
They're all joined in pairs. Oh, that vastly changes the problem. So that was just like horrible misreading. So if we have 3 points, then it's got to be like that. So that's 4. If you have 2 points, it's 2. If you have 5 points, It's
1 plus n times n minus 1 times n squared minus 5n plus 18.
Where'd you get that
24.
formula?
I had a feeling.
Well, we're about to summon the devil here.
Don't draw that, you'll get demonetized. Not okay.
So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's almost as if it's equal to that.
Right, so there's always one more than we would expect there to be. So this is actually 10 with an extra 1.
According to this, you mean?
Yeah.
So the 1 accounts for something. Just to verify, to plug and chug, if we try this for 3, we're going to get 3 times 2, which is 6. And then inside here, we're going to get 9 minus 15 plus 18. So that's 3 plus 9, which is 12. So we've got 12 times 6 over 24, which is going to cancel down to 3, I think. And then this, I'll buy it. So how would you... The proof of this is just going to be induction, probably, because it's for integers. You'd have to show... So...
Yeah, I mean, we could try to, like, intuitively understand it, but also just you could substitute in n plus 1.
Brute force induction.
Be all like, look, dog, it is.
All right.
But I guess I'm not sure if that proves it or how that would work.
I think it... So, show n plus 1. P of 1, which is just 1 plus 1 times 0. Rest of the stuff is destroyed. Fuck it. Okay, that's good. And now assume that shit. And now we want to show that that implies plugging in n plus 1, which is going to be a nasty ass, like 1 plus n plus 1 times... those will cancel, so n times n plus 1. Oh my god, this is going to be bad. Squared minus 5 times n plus 1 plus 18 over 24. So basically, we have this as true, and we have to use that as the inductive hypothesis to show that this holds, which I'm guessing...
I can't remember what the maneuver was that, like, actually makes this proof. Because, like, by substituting in, we have to show that this can be rewritten in a form that's, like, obviously something else.
Yeah, we have to show that... Well, this is going to be a geometric proof, right, of some kind. We have to show that this, similar to the other one, is very clearly the same as
Yeah, we have to include an equation containing a sub n plus 1, I think.
yes. We have a sub n as true, and we want to show an equation containing a sub n plus 1 So a sub n plus 1 is going to be in there. We know that. What would it be equal to, though? This is where I get fuzzy on proof by induction. Like, I'm not exactly sure. I know we're trying to show this is true based on this assumption.
I mean, so we're trying to show that this correctly predicts the number of parts in a thing divided by n plus 1, and we know that this correctly predicts the number for
Right.
n.
Right.
So what we have to do is take that and then say, look, if we divide, then we add this many parts, and then we'll rearrange it and see that it could be factored into this. So we have to, when we add something, how many new parts does it add? Do we know?
It adds... That's a great question. I mean, let's see if just from like the trivial example we can figure this out. So like for the previous two steps, so here's 2 and here's 1/0. So it's going 1, 2, 4, and then this was 11. Which means that this is going to be in terms of n. This difference is 7. Is this? Yeah. Fuck. That's tough. Oh, wait. Someone said connect the adjacent pairs. I guess that's mandatory.
Looks even more evil now, dude.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right, that's less bad than 11, right? Looks like it's doubling up until it jumps to 15. What the fuck? So there's some amount.
Yeah, so I'm not sure how we can construct n plus 1 from n.
If we simplify this out, do you think we'll see any kind of... Well, we don't really have an equation.
Okay, so we have 1, and then we add a line and we get 1. And here we have 2, and we add a line and we get 2. And here we have 3, we add a line, and we get a lot.
Yeah. We get a lot. Yeah, just not intuitive. Would it help if we add strong induction here at all? Like if we also have, if we're assuming a to the like a0 ... all the way up to a to the n, you can use any assumption within there is true. Does that help?
I don't know what you said, but wait, if we have 4 points, how many are there? Is it 7?
Oh, yeah, why did I skip? Wait a minute. Oh, yeah. Right? 8. 1, 2, 4, 8. Is that really 15? No, it's 16.
What?
It has to be, right? 1 in the middle, then there's the 5 points of the star, then there's these 5, and then there's the 5 outer slices. So that's 3 5s and a 1.
Well, it's not 2 to the n. I mean, this can't be 2 to the n. Are they fucking with us right now?
There's no way it goes 1, 2, 4, 8, 15. There's no way. There's no way. Man, this is why I never did math Olympiads. Even though they're so attractive. So it does seem like 2 to the n is actually the factor. Unless someone's trolling, no, you're right, it goes 1, 2, 4, 8, 15, 31. No, that was a miscount.
So if you do 6, and then I guess we've done exactly what the book said we had to do.
Do I have to? All right, 1, 2, 3. 1, 2, 3. Okay. I don't really want to count this. All right.
Figure out some of the adjacent ones. This guy just doesn't understand adjacent lines, I guess. So we can go around the edge and we get 1 for every point, so it's 6. And then we go inside and it's broken up radially so that it's radially symmetric, and every section has... I can't tell how you've drawn this. 4 maybe, and then there's the +1.
Yeah.
4 times 6 is 24, plus the 6 is 30, plus the 1 is 31, unless there's not.
Please don't be 31. I mean, one, two, three, four, 5. That's also 5. That's also 5. This is 16, isn't it? It's so hard to count this. 3 parts could not converge, yeah, so we can't, these middle lines are illegal. Dude, this is outrageous. Okay, I'm gonna do this way more carefully. 1, 2, 3, 4. Okay. So this is okay, but drawing this third line is not okay, so we're not going to do that.
Yeah, that's all right. They're just saying that the points can't be equal to each other on the edge of the circle.
No, I thought they couldn't be tri-co-concurrent or whatever.
Maybe.
Okay, we got some tiny wedges here. So maybe we count as we go. So you were right, that's 6. Then, are we not allowed to... Okay. That's allowed, I think.
Well, we just have to pretend that you didn't space the dots equally.
I'm bad at pretending. Is there anything missing here?
Yeah, there's one across.
I thought we couldn't do that because...
No, he's got to curve around so it doesn't touch the middle.
Oh, dude, I'm dumb. Yeah, like they could be slightly ajar, basically. So that's 6 on the outer. And another 6 on that, right? Is this missing anything? And then in here, 1, 2, 3, 1, 2, 3 is another 6. That was this, and then there's 1, 2, 1, 2. And then there's the center one, which is going to give us... There's no way that's right.
What? What, dude? Oh my god. No, you just forgot some lines. You forgot one here.
Oh,
and here.
If you're broken, it does that sometimes. Oops. Yeah, this book is full of typos anyway.
So I'm only going to draw one of the radial symmetries here. So there's a middle point, but nobody actually is allowed to go through that. So there's one. Oh, and this guy goes here.
No 3 pairs can... Oh yeah, that's a better drawing. I'm not even sure that 15 is right.
So I only care about this corner wedge. And the only things that can impact that have been drawn already. And I'm noticing that only these 2 affected it. So there's 1, 2, 3, 4, 5. Of course, this thing is fucking me up here, but I'm only counting 5 here. And then the other ones share some of this, which is where all these nasty pluses and minuses are coming from.
This is a really nasty... nasty problem, to be honest.
It's like when we add one, I think that, well, yeah, I don't know. So just look at the answer, like, because I've just forgotten whatever wisdom that somebody figured out.
Yeah, I guess so. Little pro tip, if you're ever like struggling to solve a problem after investing a bunch of time, you should give up. 6, 1 with 5 regions plus 1 in the middle. Not sure.
I don't know where it is.
Did you just find this for free?
What is it?
This textbook?
Oh, yeah. Trick is putting PDF in the search. Gives you PDF. Dude, I am not smart enough to get... I went past it somehow. They have like the most bizarre...
It's British. Everything is on the other side of the page.
It's like instead of putting... Like they put the exercise number and then in parentheses the page number right next to it. In the middle of the page, so I have to scan through the entire page to find it. Instead of just putting it at the top or the bottom.
Dude, blame Carlos, not me.
It's his fault that everybody in England, or the guy who wrote this book, it's Carlos's fault that he did it this way. It's probably a table of contents, but I cannot be bothered. So listen, this is problem 26 on page 57. So exercise.
What's this problem called? One of the viewers has got this is like a pretty famous problem, right?
I remember doing it.
Really?
Yeah, I've solved every discrete math problem there is, but I forgot some of the answers.
It's Mosier's circle problem. And there's a 3 blue 1 brown video on it. Will all be. There seems to be a 3 blue 1 brown video about everything.
I can't find it, dude. I don't know where it is. It's probably not even, there isn't an answer.
Yeah.
But so like there's this formula, guys, and I guess the answer is you have to know the formula.
Well, you just have to verify to verify the formula, to do a proof by induction on the formula, we don't actually have to draw things out. It's just...
I just can't remember like the actual important thing, which is what the like, maybe if I say the sentences, it's like, listen, A of n or AN
Yeah.
accurately predicts how many lines occur in a drawing with n, okay? And then I would be like understand the problem, and it would be like, listen, I drew one more line, and obviously this many more regions got added. And then I'd rearrange it and say, look, this is the definition of A of n plus 1. So obviously it's legit. So like there's a recurrence here or something, and it's probably like every time you add a line or a point, the number of points gets added again or something like that. And we just have to observe this. But I'm not sure how we would be so certain that adding 1 does the same thing every time.
Well, it clearly, like, they're saying we have to prove that it's predicted by this, which is far from... It's if you like multiply out the number of n's there, we're dealing with a quartic equation. So it's like the pattern is there.
Can we use algebra or something to say like A of n plus 1 minus A of n to figure out what's gets added every time? Is that a real thing? Can we like integrate it?
There's not like it's hard to integrate a discrete thing.
Well, you could just pretend it's not discrete and then be like, look, it's discrete. That was a legit strategy in class too. Everybody was like, I was like, guys, couldn't we just... Why are we doing any other strategy if we can just integrate? Look, let me integrate this bad boy. Okay, I'm not afraid of integrating things.
All right, hit it.
Now that I don't have to do it anymore.
Make sure you're in frame.
Minus n. Ugh, we're still multiplying, dude.
I think you're afraid to integrate.
I ain't integrating this crazy shit. I don't remember half of the rules.
Nobody does manual integral anymore.
N to the 4th minus 5n cubed plus 18n squared minus n cubed plus 5n squared minus 18n. I guess we're just distributing over 24 now? No, we're going to put that in front because I don't deal with that.
There's no way you're actually going to integrate this.
I'm not even sure if integrating or deriving is the correct solution here, but I don't need to know.
No, it's most certainly not.
What isn't?
Integrating this.
Why not?
Well,
I want to see what happens every time we add one to it. That's probably what integrating is, right?
If you want the... wouldn't that be the derivative? And also, I'm not even sure it's possible to... Like, this is, like, not continuous. Like, I don't know if either of those things is defined for this. Like, I don't know if...
Yeah, I mean, they're only defined at the points. So we'll just only ask it at the points. Okay? We're only going to ask at the points.
I mean, I guess so. I'm not even sure.
But we have to put... Easy, I can't because I put n here. But, like, we're going to do it from a to b. And we're going to say that b is n plus 1. And a is n. And it's just going to all work out because it's really not that hard. If only I knew what 18 plus 5 was. It's 23.
Oh man, this problem, it's... This is, dude, I really don't think the solution involves any kind of integral or differential calculus at all.
Well, the thing about differential calculus is that it's not actually real. And I can't put 1 in there. Yeah, differential calculus, I've never taken it, so I know this for a fact. It's not real. Things don't, like, that's just not...
Have you ever used...
What even would that be?
Have you used a derivative ever?
Yeah, I mean, like, sometimes in the car I want to go faster, I guess.
You're that thing that, like, they say dogs can do calculus because they'll like, run along the beach and then they'll, like, run into the water at, like, the exactly correct amount of time to, like, minimize the distance if you have, like, two different rates of change. But that I don't know, that's like saying children on a swing set understand pendulum harmonics. Like, no, they understand swing set.
Oh, because this is getting not happy. Look.
It's almost like this isn't their intention.
It's going to work. It's going to be great. Because now we're going to type it, we're going to plug this in. Everything's going to be like, haha, I was just kidding.
What? Wait, what's a to b here? Can only be one value.
No, I'm just doing it for all the values in case we need it again, I guess. I don't know. I mean, we don't know what the value is. I mean, I guess I could just make this a plus 1 if that's easier. But
Bro in plaid looks like he could be a prof.
Well, I can have like the same voice tones as a professor, but I cannot actually do anything. Is the problem?
Yeah, being a professor is pretty sweet. Maybe it's not. I don't know. Like, is it that hard to get a PhD if you just, like, go to the shittiest universities possible? Like, sure, like, PhDs are not created equal by any stretch of the imagination. PhD in math or computer science compared to a PhD in English.
Yeah, I'm really not understanding calculus well enough anymore to know what I'm doing anymore. Yeah, I give up. But we can't find the answer, so we're like not only not smart enough to find the answer, but we can't even find it in the book.
Damn. What a state of affairs. Turns out being good at stuff is hard.
I remember I had to solve something like this in 4th grade, and I don't think the teacher understood how difficult. She was just staring at me like, "Look, it's like, look, of course you just have to." It was a much simpler version of this, but it was like, dude, I can barely add numbers right now. I can't. I don't remember what 9 times 9 is. 9 times 8. I mean, give me a break.
Can you do that now?
70 something, 72. You never have 9 of something and then need to multiply it by 8. That's just not something that happens, guys.
It's super easy. It's basically just an extension of unemployment. You literally just spend 3 years writing shitty papers that no one will ever read just to boast about it and delay adulthood. Man, academia is awesome. It's too bad you dropped out. You're missing out on a lot. It's too bad I re-enrolled. What is this made-up nonsense that'll never apply to anything?
Well, listen, Sylvan, just ask anybody and they'll tell you how important going to college is, okay? So just, it's... I can't remember anything they say, but they say a lot.
Yeah, I mean, one thing I will say is, like, the introductory courses of college are trash now. They're like, if you know what you're doing, the real problem with college is that you can't skip introductory courses. Like, beyond introductory courses, though, like 3000 levels, are like, they actually take stuff seriously. Not across the board, and it's probably different college to college, but like, now I feel like I'm in all serious classes. It's just like the gen ed requirements, some of them, and some of the like early CS classes that you have to take and can't skip are just outrageous. Like, if I was gonna redesign school and make it not suck, that would be the biggest thing. Like, just allow people to skip a lot more. Like, allow people to test out of.
Most of the time, if you just go and tell people that, they'll let you do that. Like, I got to school and I skipped like the first 2 years of programming courses or something. It was like,
I did too,
I was
but
like, "Pre, please."
I couldn't skip gen eds.
Oh. Yeah.
That's my gripe. Like, I couldn't skip. Yeah. Alright, let's do one more. Let's try. How do you feel about functions?
I don't know. We could do functions.
All right. Nah, none of those are interesting proofs. Okay. All right. How about this? So, f is a function from x to y. With a graph, g sub f is a subset of x cross y. Prove that f is surjective if and only if for all y and y. X cross the set that contains y, intersection g sub f is not the empty set.
Yeah, I can't remember that.
Damn.
What is it?
9.6.
So we have a function mapping the set x to the set y, and it's f.
Correct.
So what does it mean for a function to have a graph?
G sub f is a subset of x cross y. Well, a function is just a mapping between two sets, right? And the graph of a function is maybe just like it's a subset of the Cartesian product of those two, so it's like not fully. Yeah, I do not.
Yeah, I mean, that's like, if you want a graph, you need to have a set of points and a set of edges. And it's like, are we going to assume that, like, what is the set of, we don't know enough. That's silly. I mean, this might just be outside of what I know.
And surjective is like the entire output set is covered. Like for every input, there's an x such that there's an output.
Wait, so what is injective?
Injective is the other way, where...
So what is surjective? Is it everything in the range can be reached, or everything in the domain?
Everything... Surjective is everything in the range can be reached, or the codomain. And injective is every... You know, it's honestly... if no element of y is assigned to more than one element of x, i.e. the function takes a different value for each point of the domain. That's the basic.
What? That's like two different things. So injective is the same as onto. And there was a third word that I forgot.
Surjective?
No, but it was my math teacher. She always had three different words that she always said every time. She said it was a function is surjective, or other, like, also called faithful or epic. Those are it was really funny.
Well, injective is one-to-one. Surjective is onto.
One-to-one is bijective, which is both of the things.
No, or that is injective or one-to-one. I don't think necessarily, because bijective is one-to-one and onto, according to this. If f is both an injection and a surjection.
I do not know. I do not know.
Yeah, I might be too fried to solve this tonight, to be honest.
What was the question again?
Dude, I don't even know what a graph is in this context. F from x to y be a function of the graph G sub f subset x cross y. Prove that f is surjective if and only if for all y and y x cross that y intersection the graph equals the empty set. For every y for the benefit of that one guy. 9.6.
F is surjective if and only if every y. Alright, it's like this set is not 0 when x cardinality is more than 0 and when y is contained in G sub f. Now, I have to tell you, y is not contained in G sub f because the type of G is xy. So maybe order operations, I'm not reading that right, and you'd have parentheses around x cross the set of y.
Yeah, I think you would. I think that's a good point. You would have to, because otherwise this just doesn't make sense. Because that would always be the empty set.
So it's surjective means all the codomain things can be reached. And I just don't understand what graph of f is. I can't. Like, what?
Well, clearly based on like just the type, it's a subset of a Cartesian product. So it's a set of edges. It's a set of tuples of 2 points. Like, it doesn't exactly matter. I guess that's what they're calling a graph. The mathematical definition for them is just an array of points.
Oh, okay. All right. It's like a graph that you draw, and that's the. All right. And it's surjective, which means that all of the y's are accessible from some x.
Yeah.
And that is the case only if every y has a corresponding x in the graph for that y. Yeah, I mean, that's okay, right? Does that seem obvious to you now? Like, that's what it is, guys. Like,
Yeah, that does seem pretty obvious. The actual proof, though, is...
So to like prove it the one way that for all y there will be a thing in there is like, I mean, suppose there wasn't, we'd be able to show that it was not surjective because you couldn't access the thing.
Which way is that proving it?
Proving that given that f is surjective, then that will be true for all y.
And then to do it the other way, if you're given that, you have to prove that it's surjective. You have to somehow...
I mean, it's like, look, we're just going to show, listen, all of the y's are in the set of things, and if all of the y's are accessible, that's literally the definition of surjective. So I think I would be writing that proof with an air of, like, sarcasm and condescension.
Yeah. Yeah. All right.